Today's talk is actually about TM30, which is a technical memorandum from the Illuminating Engineering Society related to how we can quantify and measure light source color rendition. So today, we're not really going to talk too much about the technical components of this, but rather Mike and I are going to talk about how the standard came to be, offer some generalizable knowledge about the ingredients and the process for launching a successful standard. So we're motivated in developing a standard by a desire to really preserve and reproduce what we believe is one of humanity's most fundamental sensory experiences, which is the sensation of color. It may not be understood by the general public, but light sources are what reveals color in objects. So if we think about the field of color rendering is integrating tools and techniques from color science and applied illuminating engineering. So measures of color rendering aim to predict and communicate how light sources ultimately reveal color in objects. The International Commission on Illumination in 1964 introduced the first measure. It was called the CIE, Color Rendering Index, often just abbreviated CRI. And that worked pretty well, actually, for the light sources that were available at the time back in the mid 1960s. But it really wasn't until the late 1990s and the early 2000s when LED light sources, light emitting diodes, came onto the market, where the problems or the shortcomings or limitations of the color rendering index really began to reveal themselves. And so a need was identified to develop a true new measure of light source color rendition that would be applicable to LED light sources as well as other light sources. So indeed, there is a trade-off between color rendering quality and energy efficiency based on how energy efficiency and color rendering are quantified. And so even though energy efficiency is often quantified in the limited sense of lumens per watt, the lighting industry recognizes that lighting is actually doing more than just something for energy efficiency and just something for vision. It's also providing amenity in the visual environment. And since color rendering is more important than just amenity, it's also how we judge a person's health. It's how we see and navigate. We recognize that we need a more complex set of quantification tools or metrics for evaluating both color rendering performance and energy efficiency. And our TM30 method that Mike is going to describe here momentarily is one way that we're addressing the color rendering component of lighting quality.
2013. And at this stage, the lighting industry was at a point where past efforts to standardize new metrics had dragged on for a long time, but we still had this large body of scientific research that can really demonstrate the potential for improvement. On the other side of this chasm we had to cross was the professional community in lighting that was at that stage, I would say, very receptive to new tools. So we formed a task group within the Illuminating Engineering Society, which was really meant to try and bridge this gap here. One of the things we had to do in all of this was bring together all the constituents. And might think lighting's pretty basic, but it touches on a lot of different organizations, a lot of different people who have a vested interest in how this metric might influence their business or their environments or their work. It's been a really interesting road. It has been a stormy road at times. It's taken a lot of perseverance from a lot of people, a lot of research, and a lot of different fronts. But I think we all hope that this continues to make positive change for society in our own small little way. We had decades of research. We had a lot of know-how on how to do these things, but that opposition to change and also a little bit of the politics of it. In that sense, what I'm meaning is there's research groups around the world who have been working on this for sometimes their entire careers. They've made proposals that they think are really good. They have data that shows, hey, our metric works really well. But there's another group saying the same thing. And we're at a stage where everyone thinks their own idea is the best idea, and so we have to have the political discussions of who's in charge of this, how do we work together, how do we compromise to reach a consensus solution that everyone can feel a part of and can feel good about going forward.
A university, say, promotion and tenure committee could look at something like being involved on a standard and not know whether my involvement was one of the people that was actually driving it forward or whether I was one of the people that was sort of on the committee, but sort of like quietly not doing any of the work. And often what I've observed in promotion and tenure discussions is that this kind of work is not as valued as I wish it were. I think that's unfortunate because it's high impact work. It's also cross-disciplinary. It requires a lot of time in collaboration. There's a lot of investment that goes into consensus building. And ultimately, it can be highly impactful when it works out. In fact, often much more impactful than, say, an article. So the way that we manage some of this, the committee members that were involved in this kind of promotion and tenure type of considerations, was by publishing. So even though I would say the most important thing we published is TM30, Mike and I and others on the committee also wrote journal articles that were peer reviewed. From the university's point of view, they tend to value those peer reviewed journal publications maybe higher than the standard TM30. But we were able to kind of do that both and meet multiple sets of criteria.
It was a small group of people that were really vested and active. Sometimes in standards organizations, you have committees of 30 people where 25 of those people are there to observe the process and report back to their organization what might be going on, but they aren't vested and active in contributing to the development of material for that process. And so it was specifically chosen to be small as the group that originally developed this. It went through approval processes that expanded that net considerably at each stage of that process. But being able to work through some of these technical issues with the right constituents at the table allowed us, I think, to be successful in the end. My one major contribution, perhaps, was that I didn't bring baggage to this from prior efforts. In 2013, I was a couple of years out of grad school, hadn't been in the trenches for a couple of decades, duking this out in other standards committees. So I was able to, take on a leadership role where I could be somewhat objective in evaluating all this research that was out there and trying to pull the best pieces from all this existing research to make one cohesive system. It was interesting getting started out when you're a relatively junior person trying to address technical arguments, political arguments between people who are much your senior and very well known in your industry. But I think you just take it step by step, and generally people want to see positive change in the world, and so we're able to make that happen. But I firmly think that getting more younger people involved in standards committees, in professional societies more broadly, in collaborative research efforts, to help them build their networks at an early stage, there's a ton to learn just from the experience of doing that. So the more they can be involved, I think it brings fresh perspectives, but it also trains the next generations of leaders in the fields.
I mean, we were always trying to reach consensus on these questions, but there wasn't a structured format in the sense of we would take a vote and then we would find, what was the criticism to moving on, and then we would revote. We didn't have a structured format like that. And I think we also had a trust in one another that either was built from pre-existing relationships or built over the time that we worked on TM30. And so I guess the muddling method worked for us.
A big part of reaching a consensus standard is you just have to make decisions. you can be in an infinite loop of where you have to find the perfect solution to this. But I think we all recognize that there was immediate need for something. And so let's do the best we can. Let's discuss this, let's debate this, let's work on it, let's try and come up with a solution. And we did that a lot. But at some point, we need to move on. We don't have a 10-year time horizon for this to come out. I think that helps set the stage too for how the committee looked at problems and moved forward. We had this metric, it finally passed in 2015. It made it through all the various committees that had to ballot it. Yay, pat ourselves on the back, let's all go home and go on from there. In reality, that was the beginning of the story. That was 10 years ago, and we are still, in some sense, working on this issue. Because, as I mentioned, resistance to change can be strong. Starting in 2015, there were dozens of presentations and educational efforts by members of that original task group and non-members of that task group. Other people who had an interest in this and saw value in it, and those continue to this day. But perhaps, tying back again into the high bar aspect of this, there was a very large research effort then to take that initial TM30 method and turn it into practical guidance. When TM30 was initially published, that's what we said. We said, hey, this is a good step in the right direction for this, but we expect this to be a period of discussion and debate and learning before we get to the stage where this is in widespread use.